Hello, welcome to today's class. Today, I want us to discuss on Faraday's laws of electrolysis. Yes, specifically in today's class, we'll talk about the first and the second laws of electrolysis by Faraday. Then we'll solve these two questions here on electrolysis. So the major objective of this class is I want you to know the two laws of electrolysis, Faraday's two first and second laws of electrolysis, and then how we can use this law to solve some problems, some calculation problems. All right, so I want to start by stating Faraday's first law of electrolysis. This law, the first thing you need to know about Faraday's first law of electrolysis is that it is a law that connects the mass of a substance that is deposited, that is melted, okay, during electrolysis. The amount of substance that is melted during electrolysis. This law connects just two things, just two. It connects the mass of a substance to the quantity of charge that is passed through the substance. That is what the first law does. So look at it. This is the first law. It states that the mass of a substance deposited during electrolysis is directly proportional to the quantity of charge that passes through the electrolyte. So that's the first law of electrolysis, that the mass of a substance, it can be the mass of copper, it can be the mass of zinc, it can be the mass of any metal, any substance that's an electrolyte. So the mass of a substance M gener- deposited during electrolysis is directly proportional to the quantity of charge or quantity of electricity that is passing through that substance or that electrolyte. So that's Faraday's first law of electrolysis. But you need to know that quantity of electricity Q here is equal to IT. Q is equal to IT, where I stands for current. This Q is quantity of electricity. The Q is quantity of electricity. The Q is quantity of electricity. Why? The I is current. The I here is current. The I is the amount of current, okay, that is passed through the electrolyte. The amount of current that is passed through the electrolyte stands for I in amperes. Current is measured in amperes. And T is in time. The amount of time, it stands for time. The amount of time that the current passes through the electrolyte. The T here stands for time. The amount of time that the current passes through the electrolyte. That is Faraday's first law of electrolysis. The mass of a substance deposited during electrolysis is directly proportional to the quantity of charge that is flowing through that substance, which is called an electrolyte. So that's the law. Okay, it's supposed to be ZIT, because since we have removed the proportionality sign, there's a Z there, ZIT. So Q is equal to ZIT. The Z is the constant of proportionality. Okay, all right. So that is Faraday's first law. Now let's state Faraday's second law. This is first. Faraday's first law. First law. Michael Faraday's first law of electrolysis. First law of electrolysis. That's it. That we just stated here. As a student, you need to know. As a learner, you need to know what this law states. Okay. Electrolysis. This is electrolysis. That's Faraday's first law of electrolysis. All right. So now let's go to the second law. The second law of electrolysis by Michael Faraday states that when the same quantity of electricity is passed through a solution of two or more electrolytes, the number of moles of each electrolyte is directly proportional to the mass of the electrolyte that is deposited during electrolysis. When the same quantity of electricity is passed through a solution of different electrolytes, the mass of each of the electrolytes is deposited based on the number of moles of the electrolyte, the number of moles of the electrolyte that is liberated during electrolysis. What does that really mean? For instance, look at copper. This is copper in the solid state. When this copper undergoes electrolysis, it loses two electrons. Basically, in the basic form, copper becomes copper 2 plus. It becomes copper ion. It undergoes electron loss. Loss of electron, that's oxidation. So it becomes copper 2 plus, losing two electron. Okay, because of the nature of copper, it loses two electron. Now let's bring another element, aluminium. Aluminium is also a metal, the solid state. Now, for aluminium, when it undergoes electrolysis, it becomes aluminium ion, but aluminium ion now has a charge of 3 plus. Aluminium ion has a charge of 3 plus. So that's aluminium ion plus 3 electrons. So you can see, and if the same quantity of electricity is passed through a solution of copper and aluminium, copper will deposit, the mass of copper that will be deposited will be equivalent to the number of moles of ions. The number of moles of ions of copper that will be produced. What I mean by that is the number of electrons that will be produced by copper. Then the mass of aluminium deposited will be proportional to the ions that will be deposited by aluminium. You can see the same quantity will pass through copper. Copper will produce will lose two electrons. But when that quantity of electricity is passed through aluminium, aluminium will lose 3 moles of electron. So the mass of copper is proportional to 2 moles of electron during electrolysis when current passes through it, while the mass of aluminium is proportional to 3 moles. So each element has the mass being proportional to the specific number of moles of that element. So that's what Faraday's second law of electrolysis implies. It therefore means that anytime they give you a question on calculating the current or the time or the quantity of electricity that is passed through electrolyte, you need to know that compound, that element first. If it is copper, you dissociate it like this. Write the half equation like this. Then you know that, oh, on a general note, the mass of copper is actually equal to 2 electrons. I want you to know that these 2 electrons is the quantity of electricity. These 2 electrons is the Q, quantity of what? Electricity, and it is measured in farads. It is measured in farads. The unit of quantity of electricity is farads, basically is farads. But that's not the only unit of quantity of electricity. It is also measured in coulombs. It is measured in coulombs. So quantity of electricity is measured in two ways. It's measured in farads and in coulombs. Now, oh, this is a U. Now, there's a relationship between farad and coulomb. There's a relationship between farad and coulomb. 1 farad, 1F, which is 1 farad, is equal to 96,500 coulombs. 1 farad is equal to 96,500 coulombs. Why am I stressing this? I'm stressing it because sometimes they ask you to find the quantity of electricity in farads, while sometimes they ask you to find the quantity of electricity in coulombs. So you need to know when to use coulombs and when to use farads. Believe that that's clear. So this is the idea that you need to know. Okay. And as I said before, quantity, if they give you current and they give you time, if you multiply the two of them, you are still going to get your quantity of electricity. So with that now, we are going to solve the first question. I'm going to clean this one here so that there'll be space for us. Okay, let me see if I can shift it to one side. But I think, no, the space will not be enough. So I'm going to clean here so that we'll solve this first question on Faraday's laws of electrolysis. And I know to solve Faraday's laws of electrolysis, the second law applies more. The second law applies more. The second law applies more. So look at what we have, the question that we have here. First, I want you to know that when they give you a question on calculating Faraday's law, on Faraday's law of electrolysis, first you need to know the compound that is given to you and write the half reaction for the compound. For instance, now look at this question. If 2 Faradays of charge are passed, how many grams of copper will be deposited? Now, as this question has dropped, you need to know that there's a standard from Faraday's second law. There's a standard number of farads that copper will produce during electrolysis. For every element, once you see a question on electrolysis, you need to know the standard number of moles of ions or farads that element will deposit. And that number of moles is equal to the charge of the element. So look at copper. When copper undergoes electrolysis, first you need to always first write this equation. When copper undergoes electrolysis, this is copper solid in the solid state, it will become copper ion. This is copper ion, copper 2 plus 2 electrons. Now, it therefore means that, and I told you before, that this electron here means farads. It means farads. So it means on a normal state, 1 mole of copper will produce 2 moles of electrons. Okay, and this 2 moles simply means 2 farads. It means 2 farads. And what is the mass of 1 mole of copper? This is the one that is given in the question. Molar mass 63 point. This is before solving the question. 63.5 grams of copper. Oh, let me write that 0.5 there. Let me write the 0.5. 63.5 grams of copper will produce 2 farads. This is without answering the question. If they give you for aluminium, you write the half equation for aluminium, and then you know the mass that will produce that number of farad on a general scale. Now, as I've written this now, we will now go to what is asked in the question. The question now says, if 2 farads or faradays of charge are passed, how many grams of copper will be deposited? Now, this is the standard. 63.5 grams will on a general note will deposit 2 farads. So they are asking us now that if we have 2 farads of charge, how many grams? So look at how I've just done it. On the general scale, on general note, 63.5 grams will produce 2 farads. That's the basic one that happens always. But in the question, they're asking us for 2 farads. So I will come to this farad side and put 2. Then on the mass side, we don't know. So what do? We cross multiply like this. We'll say, okay, 63, let me come to the side, 0.5 grams times 2 farad is equal to 2 farad times x, 2f times x. So we're looking for x. We're going to divide both sides by 2f, 2 farads. We're going to divide both sides by 2 farads. Once we do that, we're going to get the grams of copper that will be deposited. And if you divide by 2 farads, you see that, oh, you have 63.5 grams. So it means that 2 farads will still end up producing 63.5, the same grams of copper. It's like that because on a general note too, normally copper actually loses 2 electrons, and that's 2 farads. So that's why there's no change. I hope that's clear. All right. So you can pause the video, look at it again, and try to get what I've just explained. So the mass of copper that will be deposited by 2 farads of charge is 63.5 grams. So the next now, we're going to calculate this next question on how on which element is here. This is silver. This is silver. All right. Now, first, the question says calculate the current required to deposit 0.5 grams of silver in 10 minutes. All right. So, the first thing we need to do is write the equation for silver. Write the equation for silver. Silver is always in the solid form. When it undergoes electrolysis, the charge of silver, go practice the charges of metals and non-metals. You can check the electrochemical series to practice the charge of many metals and non-metals. This will help you. If you don't know the charge of silver, you won't get it. So silver, from normal chemistry, we know that silver has a charge of +1. So it means it loses 1 electron. So that's silver plus, then plus an electron. Silver plus an, it's not like copper that loses 2. So silver plus, and then it will lose 1 electron. Okay, this is the oxidation of silver. I told you once to give you a question, first you must always write the half equation. So silver in solid form has undergone oxidation, and that's silver plus one electron. Okay, and that one electron is, I told you before, is 1 farad, and 1 farad is equal to 96,500 coulombs. So it means that, and what's the mass of silver there? What's the mass of silver there? 107.87. 107.87 grams. 107.87 grams of silver will produce 1 farad. I told you. Now look at this question. This question says we should calculate the current. Anytime they say you should calculate the current, it means you must convert the farad to coulomb. And 1 farad is equal to 96,500 coulombs. 96,500 coulombs. And this 96,500 coulomb is a product of current and time. So 107.87 will produce 96,500 coulombs. Okay, let me clean the farad and write 96,500 because that's 1 farad. 96,500. All right, so we're making progress. We are making progress. Okay, but the question says calculate the current that will be deposited by 5 grams, 0.5 grams. So on the mass side, we have now, this is gram, here is 0.5 grams. So this 0.5 grams now, we need to convert this minutes to seconds. 10 minutes is 60 times 10, that's 600 seconds. But remember, current, quantity of charge is equal to current times time. Current times time, IT. So we know I, but we don't know T. Sorry, we know T, but we don't know I, which is current. Okay, so 0.5 grams is going to give us, now our I we don't know, so our T is 600. So our quantity of charge is now equal to 600 times I, which is like 600 I. 600 I. So we're going to put our 600 I here. Okay, so we will now cross multiply. We will now cross multiply. Let me shift it. Let me bring it to this point. We are going to cross multiply now. We have 0.5 gram times 96,500. 96,500 to be equal to 107.87 times 600. 600 I. Can you see that? Times 600 I. So we are going to now multiply them to get our values. So 0.5 times 96,500, that's 48,250. So we have 48,250 on this side, 48,250